Here we are with Prism volume for chapter 12. And if you want, you may wish to look back at the very beginning of the chapter where we started with the area review, because in order to calculate the volume of a prism, you need to know the area of the base. So here are some prisms. Think about it kind of like a cylinder, which we already discussed, except instead of having a circle and a circle as the two bases, remember in the cylinder the bases were parallel and congruent? Instead of having a circle, we're going to have different polygons. As you can see, you can have hexagons, you could have triangles, pentagons, rectangles, squares. Any polygon, you're going to have two of them that are congruent and parallel. So look at here, ceiling, floor, congruent, parallel. Now this one, you might kind of think about it like it got knocked over on its side. These are the bases, right? These hexagons are parallel and congruent. So what you really want to know for, like, once you identify, oh, this is a prism, you want to make sure you know what the bases are. Since the bases are parallel, they're never going to touch. So you'll see some where, some people will look at this and think it's kind of like a pyramid, but really this is a triangular prism. If you look at this triangle here in the front and this triangle here in the back, these triangles are parallel and congruent. So it's actually a triangular prism. These are the bases. Okay. Now, similar to when we did cylinder, for example, if you cut parallel to the base, your cross section, you can see it outlined here in red, is going to be the same shape of the base. If you cut perpendicular to the bases, slice down here this way, then the cross section will be a rectangle. Okay? The volume of a prism is the area of the base times the height. That is exactly the same as it was when we did cylinder. It's just for cylinder, the base is always a circle, so we did pi r squared times h. With a prism, we have to figure out it's a prism, then we have to figure out what the bases are, and as you'll see, some of the rectangular prisms you can use different sides as bases, and it'll still work out. So you got to figure out what are the bases, and you substitute it. This capital B here means the area of the base. So we're doing the area of the base times the height. What is the height? Again, just like for cylinders, the height is the distance between the two bases. So here's a prism. Okay? We're going to use this square that's on top. See how there's four sides of it? And this square that's on the bottom, they are two bases. So what's the shape of the base? Square. What is this solid called? Prism. So I have to do the area of the base times the height. Well, the area of the base is just going to be 6 times 6 because it's 6 squared. It's the area of the square, remember, is side squared. So the area of the base is going to be 36 meters squared. Area of the base is in meters squared because the length is in meters. The volume of the prism is then going to be that 36 times the height. Well, the height is the distance between the bases. Here's the two bases, ceiling and floor. This 8 is the distance between them. That's the height. So what's the volume? 6 squared times 8, 288. And remember, all volume is in units cubed. So far, so good, right? Now, this is a prism. It's a rectangular prism. The bases are rectangles. We're going to use the bottom and the top. The floor and the ceiling as our bases. So we're going to say the area of the base is, remember, base times height for a rectangle. 3 times 7. And then what's connecting the floor and the ceiling? This is the height, the 5. So this is our volume. But what you can notice too is, what if you had used the left and the right side here as your bases? You still would get the same answer because you would be doing 5 times 7 to get the area of this base, and then the 3 would be the height. So with a rectangular prism, it's not like there's like one right answer for what are the bases. As long as you, if it's a rectangular prism, as long as you pick one pair of sides that are opposite from each other that are parallel, like left and right or top and bottom, or front and back, you're still going to get the right answer for volume. And so here's another one. I used the 10 and the 4. The floor and ceiling as my bases, and then I use the 6 as my height. Length is in meters, then area is in meters squared, and volume is in meters cubed. Here's an example of a triangular prism. Like I said, especially once we get to pyramids, sometimes people get confused and they consider this to be a pyramid and try to use that formula. Picture a pyramid, okay? Like if you've ever seen pictures of pyramids before in Egypt, a pyramid comes to a point at the top, okay? If you can walk across the top of it, it's not a pyramid. So see this thing? Before you try to say that this is a pyramid, and again, we haven't discussed pyramids yet, but I'm saying at the end of learning all of these, you're going to have to put all of them together and say, what is that solid, and then how do I get the volume? And I'm telling you in advance, a lot of people will look at this and say, oh, this is a pyramid. No. You get to the top. Could I walk across this balance beam? Yes. If I have good balance, it's not a pyramid. All right. So then you got to say, okay, I think it's probably a prism. What are the two sides that are parallel and congruent? We'll look at this triangle in front towards you and this triangle in the back. Those are the bases. So it's kind of like, it's a triangular prism, and you can think about it like that knocked on its side, if that helps. All right. So you could also tell that these rectangles along the side are not the bases because they're intersecting with each other. Remember, the bases are parallel. So what's the area of the base? Well, the shape of the base is a triangle. So the area of a triangle is 1/2 times base times height. Now, that's 1/2 times the base of the triangle times the height. Remember, lowercase b. The volume of the prism is capital B times height. So some people get the height of the triangle confused with the height of the prism. Let's think about this. How do I get the area of the base? Here's the triangle. Think back to our area review at the beginning of the chapter. What is the area of this thing? Well, isn't it just 8 times 5, which is 40, and then divided by 2 or multiplied by 1/2 because it's a triangle? That's where I got the 20 from. 1/2 times base times height of the triangle. Now that I have the area of the base, which is capital B in the prism formula, I have to do this area of the base times the height of the prism. The height of the prism is this distance between the two triangles, which is 10. So what's the volume of the whole thing? 200 cubic feet. The volume of a prism is capital B, area of the base, times the height. Don't confuse that with the area of a triangle, which is lowercase b. Again, as you're working on homework on this, if you need to go over and look at the beginning of the chapter with the area review, perhaps that will help you.